Welcome back to the course Elastostatics, ladies and gentlemen. In this tutorial, we want to address the topic principal normal stresses. Let's have a recap of what principal stresses are. As you know from the previous sections, if you have a body that is subjected to various stresses and you alter the cutting angle of that body, the current stresses in the new coordinate system vary with the cutting angle or with the rotation angle of the coordinate system. And if you think about it, there must be an angle at which the stresses attain their maximum values. We will figure out the angle at which this happens based on an example and compute the corresponding stress magnitudes. We have a body that is subjected to normal stress sigma x and normal stress sigma y, as well as the shear stresses indicated on the sketch. The formula that we need to use to calculate the principal normal stresses is here. Sigma 1 and sigma 2 is equal to sigma x plus sigma y divided by 2 plus minus the square root of sigma x minus sigma y divided by 2, and then the whole thing squared, plus tau xy to the square. Why sigma 1 and sigma 2? Because to each principal normal stress, there's another principal normal stress that is perpendicular to the former one. And the angle at which the normal stresses attain their maximum, so that they become principal stresses, is computed with the help of this equation. The tangent of 2 times alpha star is equal to 2 times tau xy divided by sigma x minus sigma y. Once we have calculated the angle, we need to know somehow which principal normal stress corresponds to sigma x and which one to sigma y. To figure this out, use the formula for sigma x star from the previous sections, which is here. Plug the given stress values for the old coordinate system into that formula and the calculated angle alpha star. Then see whether the computed stress magnitude corresponds to sigma 1 or sigma 2. I would suggest that we start and do it together on our example. This is the piece of material in the old coordinate system. And don't forget that the directions that are labeled here are the assumed directions. And since the corresponding stress values are positive, that means that the actual directions are in line with the indicated directions by the arrows. Sigma 1, 2 is equal to sigma x plus sigma y divided by 2. Sigma x is 50 megapascal. Plus 30 megapascal. Divided by 2. Plus minus the square root of sigma x, which is 50 megapascal, minus 30 megapascal, divided by 2, and the whole thing squared, plus 15 megapascal squared. That's the shear stress. Okay, and of the whole thing, you need to take the square root. So let's start with computing sigma 1. To compute sigma 1, you have to add this square root to this fraction, which is going to give us sigma 1 is equal to 58.03 megapascal. And sigma 2, which is obtained by subtracting the square root from this term, is equal to 29.97 megapascal. And now we want to calculate the angle at which the coordinate system needs to be rotated to make the principal normal stresses appear. And the formula is tangent of 2 times alpha star is equal to 2 times tau xy. Tau xy is 15 megapascal, so it's going to be 2 times megapascal. Divided by sigma x minus sigma y. So that's how you calculate the tangent of 2 times alpha star. And that is equal to 1.5. 1.5, that's the tangent of double the angle. So to calculate the angle alpha star, you need to take the inverse tangent of 1.5. Tangent to the minus first power, or just the inverse tangent of 1.5. And that gives us alpha star actually, let me start with 2 alpha star is equal to 56.31 degrees. And to get alpha star standalone from this angle, you just need to divide this angle by 2, which gives us alpha star is equal to 28.16 degrees. And this is the angle by which you have to rotate your coordinate system to have the normal stresses attain their maximum absolute values. And because the angle is positive, the rotation of the coordinate system will occur counterclockwise by 28.16 degrees. Now it's time to draw the sketch of the rotated coordinate system. Here we go. In orange is the old coordinate system, and the blue coordinate system is a rotated coordinate system. And I should also label that the rotation angle is 28.16 degrees counterclockwise. This square is an area element that has been cut off from this body. And as you're familiar, the stresses sigma x and sigma y, sigma x star and sigma y star we know that the stresses are labeled this way, but we're interested in the magnitudes of sigma x star and sigma y star. So we want to find out whether sigma x star corresponds to sigma 1 or sigma 2. And the easiest way to find this out is simply to grab the values for sigma x, sigma y, and tau xy and plug them into this formula to calculate sigma x star. And if your computed value corresponds to sigma 1, then sigma x star is equal to sigma 1. If it corresponds to sigma 2, sigma x star will be then sigma 2. And even though you have a formula for sigma x star and sigma y star, you just need the formula for one component because the other component is automatically perpendicular to the other component. Sigma x star. I will not do the math. I'm gonna write down the value right away. It's equal to 58.03 megapascal. And as you can see, sigma x star is therefore equivalent to sigma 1. So you could set them equal. And sigma y star is then automatically equivalent to sigma 2. And sigma 2 is 21.97 megapascal. Okay. One more thing. What is the angle of the normal stress sigma y star relative to the old x-axis? To find this, that angle is simply 28.16 degrees plus 90 degrees, because the direction of sigma y star is perpendicular to the x star axis, and the x star axis is 28.16 degrees counterclockwise to the x-axis, and that is equal to 118.16 degrees. And if you want to label that angle on the sketch, you have to make the angle extend all the way between sigma y star and the x-axis. This is 118.16 degrees. So far so good. I hope I could help you understand how to calculate the principal normal stresses and the angle by which the coordinate system must be rotated to make principal normal stresses appear. I thank you for watching, and if you're looking for more videos, just stay tuned.